Good evening, students. Welcome to the session. My name is Satish. Today we will discuss about coordinate geometry, part of coordinate geometry, say like about straight lines and different forms of the equations. How can we calculate those equations? Like how can we find out the equations of lines, in different situations? And then different conditions on the lines, like when they're parallel, what happens, when they're perpendicular, what happens, and then again, like when points are given, like to know the distance of the point from a line, or to say whether the line is the point is lying on the line, like we say like they are collinear points. So what is the condition for collinearity, and these type of concepts we'll discuss today. Okay, so let us start with it. So we all know the coordinate system of axis, right? Like the x-axis and y-axis. This is the x-axis and this is y is the vertical one, and this we know is the horizon, right? And this equation of this line, the equation of this horizontal line is nothing but x is equal to 0, and the equation of this vertical line is nothing but y is equal to 0. So these are the basic two equations. And then if I have a line which is not intersecting the y-axis, or maybe say it is parallel to y-axis, cutting the x-axis at some point, say randomly at A, then equation of this line will be this should be y is equal to 0 and this should be x is equal to 0. By now you might have caught it, right? Because see, why this is y is equal to 0 and this is x is equal to 0 is on this line, however far, how much long or how further you walk, the value of y coordinate is always equal to 0. So this is y is equal to 0, and this equation of the y-axis is x is equal to 0. Here also, the further you walk on this y-axis, your x values will not change. X values are always equal to 0. Similarly, this line's equation will be x is equal to a, because the value of x always is equal to a on this line. And the same way, if you have a line parallel to x-axis and say cutting the y-axis at say certain b, then this is nothing but y is equal to b is the equation of this line. So you now know like what is the equation of x-axis. So the equation of x-axis is what? Y is equal to 0. This is the equation of x-axis, and equation of y-axis is x is equal to 0. Please do remember this, like you might get confused like how I just now did, right? Like you always should know that, like, because whenever somebody says what is the equation of x-axis, we immediately may say x is equal to 0. No, it is y is equal to 0, because the value of y on that particular line is always equal to 0. Similarly, if a line is parallel to y-axis, then its equation will be x is equal to any line parallel to y-axis, or any or y-axis itself is given by the equation x is equal to 0 or x is equal to a. And similarly, any line parallel to x-axis or the x-axis itself is given by y is equal to b or y is equal to 0, right? And then generally, see, what is the equation, linear equation general form we all know is ax plus by plus c is equal to 0. This is the general form of the equation. When you have the axis and it's cutting at horizon, and say this is the equation of the line ax plus by plus c is equal to 0. This is the general form of the equation always. It can be converted into so many other forms which we are going to discuss now, right? See, when the values, see, I want to know what will be the value here. Say suppose I want to know the value here, then what will it be equal to? Say suppose in this, if I substitute here, the values will be x comma or else some value, whatever you say the value, the intercept is some k or something, and then the y value will be equal to 0. So when you substitute that, then it will be a times k plus c is equal to 0. So the value of a is nothing but c by minus k. Or if you take this value as some x unknown value, we don't know the value of x, then what will you get? Ax is equal to minus c and x is equal to c by a. Right? So using this, like when you have a second, let me. If I have an equation, say this is a point, and I'll say this x-intercept as a comma 0, and this is the 0 comma b is one more line, then this equation is given by x by a plus y by b is equal to 1. This is called as the intercept form of the straight line, where a and b are the intercepts on x-axis and y-axis. Now let us quickly list down a few types of equations, means a few forms of this general form of the equations. Like one is y is equal to mx plus c. Here again c is nothing but y-intercept and m is the slope. What is slope? Slope is nothing but the difference in rise and run. Like slope is nothing but the change in height, which is nothing but y2 minus y1, like how you are increasing with respect to x2 minus x1. This is called as slope. You can also write this as y1 minus y2 by x1 minus x2. So both of them are same, because you are changing the difference, you are taking the difference in order. Here if you take 2 first, the second point first, here also you take the second point first. If you take the first point here, then it will be the first point. So now this equation can also be written as y is equal to y1 minus y2 by x1 minus x2 times x plus c. If you don't know the slope, like if slope is not given, then he'll give you 2 points, or maybe sometimes he'll say this is a point, and then the line is passing through the intersection of 2 other lines. Then you solve those 2 equations by simultaneous, and then find the point, and then you find the slope and then substitute here. So y is equal to mx plus c is called as the gradient. See, slope is also called as the gradient. It's the gradient form of the line. Sometimes the line just passes through the horizon. So I told you, right, like c is the y-intercept. So here the y-intercept is what? 0, because it is passing through the horizon where it's cutting the y-axis at 0, in other words, right? Then the equation is simply y is equal to mx, right? So far we have seen like x by a plus y by b is equal to 1 is one form of the equation, and y is equal to mx plus c is another form of the equation, and then y is equal to mx is another form of the equation. Mx is when it's passing through the horizon, right? And then if 2 points are given, like say I don't know any other values, I don't know the y-intercept and I don't know the x-intercept or anything else. I know that the line is passing through 2 points, say x1 y1 and say x2 y2. These are the 2 points the line is passing through. Then I know the slope now, right? Like what is the slope? Slope here will be y2 minus y1 by x2 minus x1. This gives us a slope. Now the equation of this line is given by y minus y1 equals to y2 minus y1 by x2 minus x1 times x minus x1. This is the 2-point form of a straight line. This is called as the 2-point form of the straight line. You can also write this as y minus y1. If you cross multiply this here, y2 minus y1 equals to x minus x1 by x2 minus x1. This is also one of the 2-point formulas of the straight line when x1 and y1 and x2 and y2 are given. Sometimes he will give a point, say x1 y1, and he will just give the slope. He says this line is passing through this point and this is the slope. Then what is the equation of the straight line? So what you will do here is y minus y1. y1 is the point I know, which is equal to slope times x minus x1. This is also one more. This is called as point slope form. of the line. This is called as the point slope form of the straight line, where x1 y1 is the point and m is the given slope. So when slope is given, you don't need 2 points, he'll give you only 1 point and then you can find. And sometimes when the slope is not given, he will give you 2 points from which you can find the slope and then figure out the equation of the straight line. And there is one more form of the equation, like you can write it in the determinant form, right? So you can write it as x, y and 1, x1, y1 and 1, x2, y2 and 1 is equal to 0. If you calculate this determinant also, you will get the same equation. You will get the equation of the line, right? So you can even find the equation when you know x, y and 1, you take them as the variables, x and y as the variables, and given points you substitute here, you can easily find the equation of the line when you use this determinant. Then if sometimes, so how it will be is there is a line. I want to find the equation of this line, okay, which has an x-intercept say a and a y-intercept b, okay. If these are not given, I'm assuming them, okay. Okay, we'll do one thing. So if these are not given, say we'll talk about this later. Say suppose the perpendicular from the origin is given, the length of the perpendicular is given as p, okay, and this equation we have to find. And he gives that this perpendicular makes an angle of alpha with the x-axis. Okay, so how to find this equation of the line when you don't have these values, right? Only alpha is given and p is given. The distance from the origin to the line we know, and the angle alpha we know. So see this, what I will do is I'll take this as a. This is my assumed value. I'm not, you know, it's not given to me. If it is given x by a plus y by b is equal to 1, okay, but I don't know that, right? Like these values I'm assuming, and I want to relate these to this perpendicular distance from the center to the line, right? So I'm assuming these to be a and b, and let us say there is a point on this, say x comma y on this line, right? So if this is there, then general equation will be x by a plus y by b is equal to 1, but I want the equation in terms of alpha and p because these are the values given to me. So I want to derive that from this, right? So now let us see this triangle. Now let us consider this triangle here. If I take cos alpha is nothing but adjacent by hypotenuse. Now since this is the right angle for me, this will become the opposite, hypotenuse, and this becomes the adjacent side. So cos alpha will be p by a, right? This implies a is equal to p by cos alpha. Let us write it as 1 and keep it aside. And then if you take this triangle, this will be 90 minus alpha, then this will be alpha. You can do anything, like here you can find cos 90 minus alpha, or you can do sin alpha from here. So I'm finding sin alpha in this triangle. Sin alpha will be given by opposite by hypotenuse. So here opposite is again p, by hypotenuse is b. So b is equal to p by sin alpha. This is equation 2. Let us substitute this in our given equation. So now our equation will become x by a. A is what? P by cos alpha, plus y by b. B is what? P by sin alpha. And this value is equal to how much? 1. So when I simplify this, it becomes x cos alpha by p plus y sin alpha by p is equal to 1. And if you take LCM and then simplify, you get x cos alpha plus y sin alpha is equal to 1. And then the final equation you get as x cos alpha plus y sin alpha is equal to p. So the equation of this line is x cos alpha plus y sin alpha is equal to p. So when a line, if you want to find the equation of the line when the length of the perpendicular from the origin is given, the length of the perpendicular from the origin is given, and the angle made by the perpendicular with the x-axis is given, then this will be the equation of the line for us. So x cos alpha plus y sin alpha is equal to p is the equation of the line, right? Also, see, we know in a right angled triangle, see, coordinate axis is right angle, right? Generally, so let us take some right angle triangle for now. Now, what did we just now discuss, like rise by run? So I'll take this as y1 and this as y2, this one as x1 and this one as x2. So slope is equal to y2 minus y1 by x2 minus x1. Let us assume this is making an angle theta with this line. Okay, so this one is x2 minus x1 and this one is y2 minus y1. In this triangle, if you take, what do we have? Tan theta is equal to y2 minus y1 by x2 minus x1. So in other words, slope, which can be denoted with m, which is equal to tan theta, and this is always equal to y2 minus y1 by x2 minus x1. So a slope also can be written as tan theta. You can write slope as tan theta, right? Tan theta is nothing but slope, where theta is the angle made in positive direction with the x-axis, right? Now, when I have this equation, y minus y1 is equal to m into x minus x1, one point formula, like point slope formula you can say. Here I can write y minus y1 is equal to m is nothing but tan theta times x minus x1. So y minus y1 is equal to sin theta by cos theta into x minus x1. In other words, you can also write it as y minus y1 by sin theta is equal to x minus x1 by cos theta. This is also one more form of the equation, which is given by y minus, when you know the angle made with the x-axis. When you know the angle made with the x-axis, you don't know the slope or anything else, and you know one point x1 y1, and then you know the angle made by it with the x-axis, then you can directly do this way. By using, you can obviously find, like, you know, tan theta from when theta is given, and you can directly do it. But this is one more form, like which we will be using in some scenarios where you need to find sin and cos thetas, right? Then see, there is something called as the parametric form of the equation, which we have just now discussed, right? Like x minus x, yeah, one second. So this equation, x minus x1 by cos theta is equal to y minus y1 by sin theta is equal to r. These all will be the ratios, this r. Then this is called as the parametric form of the equation of a straight line. This is the parametric form of the equation of a straight line when theta is the angle made with the axis by the line, right? Now, what if we have two lines, you know, making angles with each of them? Like, say, these are the two lines I have, and I want to find the angle between them. So the angle between the two lines is given by tan theta is equal to the difference of these two. See, it is not you can say, you know, if m1 is greater than m2, then m1 minus m2 you will do, or else, you know, that's the reason we are using this absolute value, so that even if you get negative also, it goes to be positive. And 1 plus m1 into m2, this will give us the angle, the tan theta's value. And if you want the angle exactly, theta is equal to tan inverse of modulus of m1 minus m2 by 1 plus m1 m2 is the angle between the two lines, right? Where theta is the angle between the two lines. And m1 and m2, what are these m1 and m2? They are nothing but the slopes of the two lines. Means, say if this is making an angle theta 1 and this is making an angle theta 2, then tan theta 1 will be equal to m1 and tan theta 2 will be equal to m2. So this actual angle should be taken this way here, theta 1. Always take the positive angle made with the x-axis in the positive direction, that is anti-clockwise direction, and tan theta 2 will be equal to m2, and you can substitute those values here to get your value of the angle between the two lines. If these angles are not given, and then only directly slopes are given, m1 and m2, he says the slope of this one is m1 and slope of this is m2, you can directly substitute in the formula. You need not find these values. m1 and m2 is already given. If m1 and m2 are not given and just angles are given, then you take tan theta 1 and tan theta 2, you find those values and then substitute it there, right? Next, when can we say two lines are parallel or two lines are perpendicular? See, when I have two lines, first we'll discuss about the parallelism. If two lines are parallel, the thing is that their slopes must be equal, m1 m2, so m1 must be equal to m2. See, it justifies because tan theta is nothing but the slope, so tan theta values are equal, that means that theta values are equal, that means the angles made by the lines with x-axis is equal in the same direction, that means they will be definitely corresponding angles. Suppose I have two lines this way and these two angles are equal, and this is a transversal, right? So the angles are equal means the two lines are parallel. That means if these angles are equal, tan values of those are equal, that means the slopes are equal. So when the slopes are equal, the two lines are always parallel. So if I take two lines, a1x plus b1y plus c1 is equal to 0, a2x plus b2y plus c2 is equal to 0. Here you have three cases. Either the two lines are parallel, either the two lines are not parallel, they are intersecting each other, or the two lines are the same line, that is they are the coinciding lines. So what are the conditions for this? When a1 by a2 is equal to b1 by b2, which is not equal to c1 by c2, that means the two lines are always parallel. Where see, if you see here, a1 by a2 and b1 by b2, if you simplify it, it's like simply b2 by a2 is equal to b1 by a1. b1 is nothing but the y variance and x variance. When this by this will give the slope, right? These slopes are equal, that means when you say b2 by a2 is equal to b1 by a1, the slopes of these two lines are equal, right? Because these are the intercepts. When the slopes, we are saying slopes are equal, but at the same time the y-intercepts are not equal. If the y-intercepts are equal, then it's a different story, we'll talk about that. So these two are not equal, that means these are parallel. And if a1 by a2 is not equal to b1 by b2 and this is not equal to c1 by c2, or this doesn't matter actually now. If this happens, then the two lines are intersecting. As the slopes are not equal, the two lines will be intersecting lines. Two lines will be intersecting lines. Now, what if it is equal to c1 by c2 also, that is a1 by a2 is equal to b1 by b2 is equal to c1 by c2. They are parallel and the y-intercepts are also equal, that means the line is the same. The two lines are the same. There is no two different lines, there is only one line which is, the second line is also overlapping the first one. So if this happens, they are same line or coinciding lines, you can say. And here it is parallel and this is intersecting, right? So a1 by a2 is equal to b1 by b2 is not equal to c1 by c2, then the lines are parallel. When these two are not equal, then the lines are intersecting, and all of them are equal, then the lines are completely coinciding. Next, if there is a line, before going there, we'll talk about this also. When you have 3 points, if you look at these 3 points, these are not collinear. Collinear is like they should be on the same line. So when can you say 3 points are collinear A, B and C? Is there are so many ways, like some say like find the area of the triangle and equal it to 0. Some say find the distance distance between AB and BC and add it and say is equal to AC. In a triangle, sum of two sides is greater than the third side. If that is not happening, then these are parallel. Coinciding is what they say. And the simpler way I feel is find the slope of AB and the slope of BC. If these two are equal, then you can simply say these two line segments are these 3 points are collinear, or two line segments are collinear, because see, you can say they can be parallel also. No, because there is a common point B in these two things. Like for a line segment AB and the line segment BC, you have a common point B. That is the reason we can simply say these two line segments are not different. They are the same line when their slopes are equal, because AB and BC are coincident. Suppose, what is the other way it can be is A and B, A is here and B is here and C is here. Now if you see the slope, this slope here is not equal to the slope of this line here. Right, these slopes are not equal, because see, you can see an angle forming here. That means this slope and this slope is not equal. Correct. So whenever you prove that the slopes of the lines AB and BC are equal, then you can easily say that the 3 points are collinear when the point is common. So when you have a common point here, you can simply say they are collinear. So always pick this version whenever you are solving this type of questions, like simply say AB and BC are having equal slopes, so AC, ABC are collinear. Now if you have a line and you have a point somewhere and you want to find the distance of this point from the line, say this point is x1, y1, and here the equation of the line is, say, ax plus by plus c is equal to 0. And the distance is simply given by, you substitute the values of x1 here, ax1 plus by1 plus c by root of a square plus b square will give you the distance of the point from this line. So you can always find the distance by using this formula without doing any other calculations. Like generally, you might be thinking I need to find a point here, and then you can find the point and then use the rule, use the distance formula, root of x2 minus x1 whole square plus y2 minus y1 whole square is equal to the distance. But here you don't need it. You can directly, using that only this formula was derived. Actually, you can derive it maybe if you want, right? This formula is used. Now let us quickly solve few questions from the concepts which we have used so far. The first question here says that prove that the perpendicular from the origin to the line joining the points c cos alpha, c sin alpha and c cos beta, c sin beta bisects the line segment. So see, there is a line segment. This is a line, but he's talking about a line segment where there are 2 points. So one point is given here as c cos alpha, c sin alpha, and one more point is c cos beta, c sin beta. Right, and this is the origin and the perpendicular from the origin. So I join the perpendicular from the origin. This is the perpendicular. He is asking us to prove that this line bisects this. Suppose this is D and I'll name this point as A and B. I need to prove AD is equal to DB or BD, whatever it is. Right? So we will simply try to join this, and OA and OB are what we are going to join. Now if you observe carefully, the distance OA is nothing but root of c square cos square alpha plus c square sine square alpha. This is nothing but c, because cos square alpha plus sine square alpha will be equal to 1, as you can take c square common and pull it out. Similarly, if you find OB, it is c square cos square beta plus c square sine square beta, and which will be again equal to c. So the distance here and here are the same, like this is also, the length of this side is c and the length of this side is also c. So in other words, OAB, triangle OAB is an isosceles triangle. And in isosceles triangle, the perpendicular drawn from the vertex will bisect the opposite side. So what can we say? This implies is isosceles, and then this implies we can say that OD bisects AB, or simply you can say AD is equal to DB. So this is how we can prove that the perpendicular drawn from the origin will bisect the line segment joining the 2 points c cos alpha and c sin alpha, c cos beta and c sin beta. The second one says that find the equation of the line on which the perpendicular from the origin makes an angle of 30 degrees with x-axis and which forms a triangle of area 50 by root 3 square units. So let us try this. Let us draw the coordinate axis here, and we have to find the equation of the line, okay, on which the perpendicular from the origin is making an angle of 30 degrees, and the area of the, so this line is forming the area, so AOB, so area of triangle is equal to 50 by root 3. So let us name this as small a and this as small b, the x and y intercepts, okay. Let us see. Now we know that the equation of this line is nothing but x cos alpha plus y sin alpha is equal to p, is what we have just learned, right? This is the formula we have learned. Now here I have x, and cos alpha is the angle here is 30 degrees. So x cos 30 plus y sin 30 will be equal to p. So I have to find the value of p now here. So this will be x root 3 by 2, as cos 30 is root 3 by 2, plus y times half is equal to p, which implies x root 3 plus y is equal to 2p, right? Right. Now what else do we know? We know that the area of this triangle is 50 by root 3. So area is half into a into b. So we'll find a and b values. So if I want to know this value of a, this length, the a value I will get when I make y is equal to 0. So x root 3 plus 0 is equal to 2p, where x I can take as a. Then a is equal to 2p by root 3. Then if I want the value of b, then 0 plus b is equal to 2p, so value of b is equal to simply 2p, right? Then area half into b into a is equal to 50 by root 3 is given to us. So half times b is 2p times a is 2p by root 3 is equal to 50 by root 3. So you can cancel the 2 and the root 3 on both sides. So 2p square is equal to 50. P square is 25. So p is equal to plus or minus 5. Now what is the equation we want? Is what are we trying to find? The equation of the line, right? So the equation of the line is this one. So x root 3 plus y is equal to 2 times plus or minus 5. In other words, x root 3 plus y is equal to 10, or x root 3 plus y is equal to minus 10. These are the two equations of this line whose perpendicular is making an angle of 30 degrees. which has an area of 50 by root 3 square units, right? And the last one we will discuss about the collinearity. We already discussed it, right? Like when the slopes are equal. So he gave 3 points and proved that they are collinear when AD is given equal to BC. So what are the 3 points? Let us mark them for reference. I'll take as A comma B, C comma D, and A minus C comma B minus D. So the slope of this, I'll find the slope. Let me name it as M1 and I'll name the slope as M2. So M1 is equal to D minus B by C minus A, and M2 is equal to B minus D by A minus C minus C. Now we have to prove that these two slopes are equal. So this M2 is simply B by A. Let us try to find this one also. If I prove this slope is also equal to this, because that will be easy for me rather than doing this part and simplifying it. If I do this here, I will get the slopes equal easily, I feel, because A minus C and A is here. So this is how you have to save your time in exams in doing in short ways. So let us try to find M3 also. Here B minus D minus B by A minus C minus A is the slope M3. If you look at this, this value is minus D by minus C, which is equal to D by C. This is M3. See, what did we do? Like now, slope of these two and these two we wanted to prove. If I prove slope of this is equal to slope of that, this also has a common point, right? Like we're putting in a common point there. So that also will work. So rather than doing these two, because here I will need to do some calculations to simplify using this and all. Now also we'll use that, but in a simpler way. Now if you take this, what is given to us? AD is equal to BC. From this I can simply say, taking A that side and C this side, D by C is equal to B by A, right? So using this I can simply say M2 is equal to M3. My slope M2 is equal to M3, where one point is common for both the line segments. Then the two line segments are not two different ones, they are parts of the same line. That means the 3 points are collinear. Understood? So when you have 3 points, you never know which order you have to place them on the line, because if they are the values, you will know, but if they are not the values, you will never know on which order you have to place on. So what you will do is you will always try to do in a simpler way by finding appropriate points to connect, so that your slopes will come easily equal. Understood? So we can say that the 3 points here are collinear as their slopes are equal. Understood? So I think like you have understood how to how to find out the equations of lines and different forms of the lines, and you have understood various scenarios of parallel lines and perpendicularity between the lines, and identifying the equation of the line when the perpendicular is given. We'll again meet with more facts about these straight lines in our next session. Till then, signing off, Satish from Toppr.